Hello all, welcome to the channel. In this video, we will look into the important function in Seaborn, which is used for data science and machine learning. Seaborn is widely used in real-world projects for data visualization, EDA, exploratory data analysis, and reporting insights. That means before we build any machine learning model, we use Seaborn to understand the data visually. Each SNS function is designed for a specific type of visualization. So Seaborn doesn't have one single plot function. There are different functions for different needs. Then the slide says the parameters differ based on type of data, numerical or categorical. For example, distribution plots are mostly for numeric data, and count plots are for categorical data. Number of variables, 1D, 2D, multidimensional. Like histplot is one variable, scatterplot is two variables, and pairplot can show many variables. Statistical computation, mean, regression, density, etc. This is important because Seaborn automatically adds statistics like averages, confidence intervals, regression lines, and density curves. Grouping or segmentation needs. This is where Hugh helps us compare categories like churn versus non-churn, fraud versus non-fraud, male vs female, and so on. Finally, the slide clearly states, there is no single common parameter list for all Seaborn functions. On top of Matplotlib. This means Seaborn is not replacing Matplotlib. It is using Matplotlib in the background. Makes plots more beautiful. Adds statistical features automatically. Simplifies syntax. Matplotlib controls low-level customization, controls figure size, controls titles, labels, controls subplots, controls saving images. Without Matplotlib, Seaborn cannot render plots. The histplot function shows the distribution of a single numerical variable. Important parameters include bins divides data into intervals. KDE adds smooth density curve. Hue splits distribution by category. In machine learning, histograms help us understand feature distribution. For example, are sales normally distributed? Is income skewed? Does the dataset contain extreme values? Before applying models like linear regression, we often check whether features are normally distributed using histplot. Kernel density estimate. The KDE plot function plots a smooth probability density curve. It is basically a smoother version of a histogram. In ML projects, KDE plots help detect multiple peaks, data skewness, distribution overlap between classes. For example, in fraud detection, KDE can help visualize how fraudulent transactions differ from normal ones. Boxplot. The boxplot shows distribution, median, quartiles, and outliers. Important parameters. X, category. Y, numeric value. Q, subgroup comparison. Boxplots are extremely important in ML because they help detect outliers. Outliers can negatively impact models like linear regression and KNN. Before training a model, data scientists use boxplots to identify and handle extreme values. Violin plot. The violin plot combines boxplot and KDE. It shows both distribution shape and summary statistics. In machine learning, it helps compare feature distributions between classes. Useful in classification problems. For example, comparing salary distribution between churned versus non-churned customers. Scatterplot. The scatterplot shows the relationship between two numerical variables. Important parameters. X and Y, numerical features. Hue, category grouping. Size and style, additional dimensions. Scatterplots are critical for ML. They help detect correlation, linear relationships, Nonlinear patterns. Before applying regression models, we check scatter plots to see if a linear relationship exists. Line plot. Line plot is mainly used for time series data. It shows trends over time. In ML projects, line plots are used in forecasting problems, stock prediction, sales trend analysis. Before applying ARIMA or LSTM models, we visualize trends using line plots. Bar plot. Bar plot shows summary statistics per category, usually mean by default. Important parameter. Estimator can change mean to sum or median. In ML, bar plots help compare aggregated performance. Example, average sales per region, mean rating per product category, useful in feature understanding and business reporting. Count plot. Count plot shows the number of occurrences per category. In classification problems, count plots help check class imbalance. For example, fraud versus non-fraud, churn versus not churn. If imbalance exists, we apply techniques like SMOTE, upsampling, downsampling. Heat map. Heat map is widely used for correlation matrices. Important parameters. ANOT equals true shows values. CMAP controls color theme. In ML, heat maps help identify highly correlated features, detect multicollinearity, select important features. Before training regression models, we remove highly correlated features to avoid multicollinearity. Pair plot. Pair plot shows relationships between all numerical variables. It combines scatter plots and histograms automatically. In ML, pair plot is used for quick feature interaction analysis, class separation visualization. It is especially useful in small to medium datasets. Joint plot. Joint plot combines scatter plot with distribution plots. It helps analyze the relationship between two variables along with their individual distributions. In ML, used for density analysis and correlation understanding. Jittered scatter plot or strip plot. Strip plot shows individual data points with jitter. In ML, these plots help identify individual outliers and category spread. Useful in customer ratings and survey analysis. Categorical scatter or swarm plot. Swarm plot improves it by avoiding overlap. In ML, these plots help identify individual outliers and category spread. Useful in customer ratings and survey analysis. Regression PLT or LM plot. LM plot adds a regression line to scatter plot. In ML, it helps visually confirm linear relationships. Before applying linear regression, we use LM plot to validate assumptions. General categorical plot. Cat plot is a flexible wrapper for categorical plots. You can switch between bar, box, violin, strip. In ML projects, cat plot simplifies grouped analysis. Define. Define removes unnecessary borders. It improves presentation quality. In dashboards and reports, clean visuals are important. That is all from my end. Thanks for watching.